the average grade is about 5% higher in gradebook second semester than first semester. So if you put out the same amount of effort you did first semester, you should expect about a 5% higher grade. So for most people, they consider that to be easier than trig, but again, you know, if you didn't really learn that stuff very well in Algebra 2, or you did learn it but you've forgotten it, then, you know, it's a trade-off. Some stuff we do a little bit quicker because you have seen it before, but most people think it's easier overall. Okay, any questions about semester overview, the plan for that stuff? Anybody do anything extra special on your break that you want to share with everybody? Too early? Okay. All right, then, so with your binder, I do go ahead and continue the numbers. So I'd like you to keep up with the binder like we did first semester. However, I will not ask for anything from first semester. So what I would recommend you do is either buy just a completely new binder or take out your stuff 1 through 57 and leave it at home, so that way you're not carrying it around all semester. But we'll just continue on, and then at the end of the year you can put it all together, and then if you ever need it again, you can access it. Now, I was saying that what we're going to talk about here with law of sines and law of cosines is not really a calculus topic. It's really, we do it for ACT. But if you ever do take a trig course, college trig course, this would be one of the units that you would do. You just wouldn't spend very much time on it. Okay, so how this is different than what we've been doing, because law of sines and law of cosines, that sure sounds like trig, and I just said that second semester doesn't have much trig to it, and it's just that you don't really need to know much trig to be able to do law of sines and law of cosines. So we had SOHCAHTOA last semester that helps us find side lengths or angles, but the catch was it had to be a right triangle. Law of sines and law of cosines are going to be formulas that help us solve oblique triangles. Oblique triangles are triangles that do not have a right angle. So this also works for right triangles, but we have other stuff to know how to do right triangles. So this is the formula for law of sines, here or here. They both say the same thing. They just take the reciprocal of these and you can get these. I tend to use this one if I'm trying to find a side length, just because the side lengths are in the numerator already. Remember, lowercase a, b, and c represent lengths, and capital A, capital B, capital C represent angle measures. So I tend to write it this way if I'm finding an angle measure. But honestly, it doesn't even matter. I will also add that since we only spend a few classes on this, we do not make you memorize these. I will put these on the quiz when we get to it. It's very easy to memorize. But again, the purpose of this is to help you, if you see them on the ACT, and on the ACT, the way they write it, you don't really need to have the formulas memorized. So, at least the way we've seen it. So, when can you use law of sines? So you don't have to memorize this, but you do need to memorize that. You can use law of sines if you have any two angles and one side length, and we will ask you that. And sometimes we refer to this as angle, angle, side, or angle, side, angle. Both of those have two angles and a side. And then the other time you can use law of sines is when you have two side lengths and the angle opposite one of them. This is referred to as side-side angle. Now, I could probably go on and on about this for a day or two, but hopefully these sound a little familiar to you from geometry. So in geometry, you use these to prove that triangles are congruent or similar. So these two you probably have heard of before. You probably didn't hear of side-side angle in geometry because it doesn't prove that the triangles are unique. So we need to put in a star by this one. This one is only sometimes works. This is actually referred, side-side angle is referred to the ambiguous case. And on our agenda that I'll put back up here in a bit, there is a video if you'd like to watch how to do the ambiguous case. It sounds pretty complicated and it's a little bit long-winded, but we will put like one bonus question on the quiz. So if you're interested in learning about the ambiguous case, it's just that depending on your side lengths and your angle, you could have no triangles, 2 triangles, or 1 triangle. So it's kind of complicated. But in a college trig course, they will make you learn that, but it doesn't show up on ACT. And since that's why we're doing this, we're not making you do this. Okay, but it's very easy to use. So if you've got 2 angles and a side, here's an example that's already been typed up. Notice they plugged the stuff into the formula. They plugged in the 3 numbers that they had, and then they went about solving for the one that they wanted. So they put sine of 48 degrees and 10 as a ratio because they're opposite each other. And they put sine of 55 and x together as a ratio because they're opposite each other. And that's using the formula. Looks like they cross multiplied to get rid of fractions, and then undid times with divide, and then to get from here to here they just used their calculator. So if you have any 2 angles on one side, you get to just plug in the numbers into your formula that looks like this and then cross multiply. Now if you're solving for an angle, so formula is not much different, but again I already typed it up for you so we can move on a little bit faster here. Notice I did the sine of x over 12. They're across from each other as a ratio. Sine of 42 over 22 as a ratio because they're across from each other. And then if you start going about solving this, they undid times 12 with divide 12, and then they got down to here. They got sine x is equal to this. Now, remember, sine x is not the same thing as angle x. Sine is always between -1 and 1, so this is always going to be a small number, but this is not the angle. So right here, you probably want to put a star in your notes because you'll have to do this for angles. You'll want your calculator to be in degree mode because we're going to want a degree. And to go from sine x equals to just x equals, you have to do inverse sine of that. That way you're asking your calculator what angle has a sine of that, and then it will handle it from there. Now, of course, you need to practice this a few times, but that's really all law sines is. If you have the right information, plug it in, you're going to have 3 or 4 things, solve for the last thing. If you're solving for a side length, it worked out like the example on the left. If you're solving for an angle, it worked out like it did on the right, and you just need to make sure that you know how to go from sine x equals to x equals. Honestly, just a couple of those and you'll realize that they're pretty easy to deal with. Okay, moving on, we've also got the law of cosines. So again, we will not make you memorize the law of cosines, but this is all 6 different ways it could be written. And it has the same purpose. It's to find a side length or a missing angle of a triangle that's not necessarily a right triangle. Doesn't have to be a right triangle. The one that I kind of like to point out is this one. Now, I don't know, 4 or 5 years ago we did used to make students memorize these before we just decided it wasn't important. But if you look at the first part of this, it's really just Pythagorean theorem. A squared plus b squared equals c squared. But Pythagorean theorem only works when it's a right triangle. If you tack on this minus 2ab cosine c, cosine because it's law of cosines, then you've got a formula that's just about ready to solve for c. Of course you'd need to take the square root of both sides. But if you have AB and angle C, then that's ready to go. If you were trying to find side A or side B, then what you're plugging in is a little bit different, but it follows a very similar format. You could solve these and rearrange them for cosine A, cosine B, or cosine C, but we will do that for you. So notice if I was trying to use one of these formulas over here, so again, you don't have to memorize these, but you do have to know when to use them. We will ask you that. For these, if I'm trying to solve for A, B, or C, I need to know two other lengths, BC, BC. So two side lengths and their included angle. Included means the angle that's trapped in between them. So the shorthand way of saying that is side angle side. Side angle is not considered that because the angle is not in between the sides. It's got to be trapped in between it to be included. Okay, or if you're trying to find a angle, look at what this is where I feel like you don't really need to memorize these, at least in my opinion, because you just look at the formulas and see what you need. If I'm trying to solve for angle A, angle B, or angle C, I need to know side A, side B, side C, side A again, or B again, or C again. But you need to have all three side lengths if you want to use it to find an angle. Okay, and then that's the only two times you could use law of cosine. Side angle side or side side side. So below I've got a couple of examples already typed out. Again, you'll practice this from a few texts. The book assignment's really not that long, but you'll try it here in a few minutes. But here's somebody that is, notice that they had side angle side. So they said here's the formula for law of cosines. They called this side A, looks like, plugged in 10 for A. Called this side B, plugged in 10 for B. Plugged in 10 for A again, plugged in 9 for B again, just like the formula says. And then this would make this angle C. So they plugged in 47 degrees for angle C. And then they had a formula. And to be honest, since you're going to need a calculator anyway, what I would probably do is I wouldn't do none of this. I would just go straight to my calculator and have it say, if x squared is all of this, then x is the square root of all of that. And again, you would need to make sure your calculator is in degree mode, but otherwise, throw it in there, hit enter, and you are done. So since you don't have to memorize the formula, you just have to know what you're doing by plugging those numbers in. It's pretty easy to do. Okay, and then on the right, an example of someone using the law of cosines to find a couple of the angles here. So they gave us three side lengths, which is when you can use the law of cosines to find an angle. So notice they said here's a formula to find it, or here's a formula to find it. They plugged in the numbers as each formula said. I'm assuming that they hit enter on their calculator there, got a really small number, because the cosine of an angle can only be between -1 and 1, as we talked about last semester. Again, you don't really have to know why anymore, but I guess it's helpful. But it's important to keep in mind that's not how big the angle is, that's what the cosine of the angle is. So just like with sine, you have to do inverse cosine of that to get the actual angle. And then what about if I wanted to find the last angle? Could I use law of cosines for that too? Law of cosines work on all the angles. Right. But of course, if you have 2 of 3 angles, you know, if you're in a time crunch, you probably just subtract them from 180, just like you've been doing. But you could always do it as a backup. So again, you got to practice plugging those numbers in, making sure you know how to use your calculator. But because we are not making you do the ambiguous case, which only goes with law of sines, you know, the formulas will they will work. If you're trying to use it when you're not supposed to, then you're not going to have enough information. But short of that, that's all it is. Yeah.
So anytime you're finding an angle, you're going to have to take the inverse of them?
Correct. Yeah. Because remember, if you're using a regular trig function, remember the input was an angle and the output was a ratio, right? When we're doing this, over here, these are the ratios, but we're interested in the angle. So if we plug that mess in, when we switch that, if we plug in the ratio, then the output of that would be the angle, which is what we really want. Okay. Anything that jumps out before we practice some of law of sines, law of cosines? Okay, to finish up the notes though, we do also throw 2 new area formulas at you. So when you have side angle side or side side side, these are ways to find areas of a triangle. And I'm not going to go through the proof of this too much, but I guess I'll do it just enough for you to see it. So right now you should know that let's call this ABC. If you want the area of a triangle, probably the only one you've ever heard is 1/2 base times height, and that's still true. But now that you have a little bit of trig under your belt, we have a way to figure out what this height would be. So normally, you don't have to go through all this, but I want you to see where it comes from. If I was looking from angle A, and I did a sine ratio, sine of angle A, that would be opposite, which would be H, over hypotenuse, which would be side B. So in that case, the height is B times the sine of A. So instead of saying 1/2 base times height, I could say 1/2 base. Oh, well, that's the one I got. Yeah, I've already got. Oh, well, I'm sorry. What would my base be in this? Which one of these sides would you call the base? All right, probably C. Most times we just call the one on the bottom the base. So base would be C, and height would be B times the sine of A. But I'm going to rearrange these two. And I'm going to highlight it. So a fancy way to say height is B times the sine of A. And all I really did was say, wait, there's a right triangle over there on the left. Let me do a SOHCAHTOA equation. But you could also do 1/2. Let's see, we've got BC sine of A, so we could have AC sine of B, or the last possibility would be AC sine of C. Oh no, that's not right. I've got C both times, AB sine of C. So anytime you have 2 side lengths, all we're really doing here is to get the other ones, and again, I'm just sparing you, but instead of putting them in this order, I might put them in this order. So now the base is B, and the height formula looks a little bit different. But if you've got 2 side lengths, and the included angle, 1/2 times the 2 side lengths you have, times the sine of the angle in between, is a quick and easy way to find area. By the way, I have also seen this on the ACT. Not nearly as common as law of sines, law of cosines, but easy questions if you were familiar with that formula. All right, and then finally, my favorite, just because this one's super common in higher mathematics, this is called Heron's formula. And if you know all three side lengths of three side lengths of any triangle, you can find the area with one formula that says take the square root of s times s minus one of the lengths times s minus the second length times s minus the third length. And then your question should be, well, what is s? So s is when you add up all three lengths and divide by, what would you guess you would divide by?
3.
Okay, so put a 3, but put an x through it. It's not an average. Everyone would guess 3 because it would be an average. It's 2 because this is called the S is for semi-perimeter. Just like a semicircle is half of a circle, semi-perimeter is half the perimeter. So again, same thing, you don't have to memorize these formulas for us. You just have to know that they exist. And for us, if we want you to use this one, we're going to have to give you two side lengths and the angles in between them. So you're literally going to get to go to your calculator and do 1/2 times one side length times another side length times the sine of the angle in between them. And if your calculator's in degree mode, you are done and you have the correct answer. If we give you all three side lengths, you're going to have to do this to figure out what S is. And then you're going to plug that in here, 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 and here. And as long as you're careful that you throw it in the calculator correctly, what it tells you will be the area of the triangle. So I'm assuming none of you guys have ever seen this one before. I've always wondered why they don't show that in geometry, just because it's so easy to use and so helpful. But anyway, so make sure that you have that copied down completely. And then you will need a blank piece of paper. So I've got a couple law of sines questions, couple law of cosines questions, a couple of that top area formula, and a couple of the bottom area formula. And if you're interested in doing the ambiguous case, again, there's nothing wrong with the ambiguous case. Until 2 years ago, we always made students learn the ambiguous case. The only reason why we're not doing it last year and this year is it's not on the ACT. It would take us about a day to really go through it and discuss it a couple times. I don't know. It's just not a great use of time. I would rather you feel a little bit more solid with the rest of it. But that number 5 on the agenda, the optional, that is a video that we looked up where someone does a good job of explaining it. So if you want to learn that, there will be like 1 or 2 bonus questions on the quiz, but completely optional. Okay, so go ahead and copy the assignment down. Go ahead and start the first couple, see how it goes. Again, do make sure your calculator's in degree mode. I would say that would be the first thing. Leave your notes out to look at the formulas, since you don't have to memorize them. And once I think you've had enough time to try a few, I will offer to work a few out to help clear up anything that's giving you issues. the short-term plan here is practicing a few of each of these with this book assignment. And let's see, it's already Wednesday, so Friday, this is an A week. Friday, I'll give you a practice assessment. So that'll give you one more chance to make sure that you're really getting out of what you need to get out of it. And then the Monday after that, we will quiz this and move on. And we don't want to spend too long on it since it's not that relevant to any math courses. But I think that quiz will be probably just like 20 or 30 points. So, of course, early in the semester, that will be your grade. By the end of the semester, it won't impact it too much, but since it's not a full unit, it won't be a 100-point test to start off. Just like a 20, 30-point quiz and then move on. Okay, I am going to go over question 5. So if you feel like you're getting it, and of course, best if you have also checked your answers in the back of the book. I guess you should also be making a habit out of making sure your answers look reasonable. Biggest sides, opposite biggest angles, all that kind of stuff. And you should know if you can tune me out here or not, but if you need some help. Give me just a second to get the question written down. And then one thing that I am flexible about here, technically these directions say use law of sines, but if you thought the information you had, law of cosines would be easier, go for it. Law of cosines is fine with me. But this one gave me 2 angles and a side, which is when law of sines will always work. So this one said solve the triangle. So that means you should be finding all the missing stuff, which would be angle A, side A, and side C. Well, to find angle A, you don't need anything new. You just need to know that all 3 angles add up to 180. So 180 we could do 180 minus the 2 angles given to us, and that gets you angle A. Which is 30 degrees. And then if you want to find side A, again, law of sines has 3 parts to it. 1 ratio equals another ratio equals another ratio, but you only need 2 parts. So if I'm trying to solve side A, I'm going to put it over the sine of angle A, and I have to set that equal to either side B over angle B or side C over angle C, whatever I think is going to be easiest. Since I don't know side C yet, I'm not going to do that. I would put it over side B over angle B. And now we have an equation. Looks like if I multiply both sides by the sine of 30, I do divide with times, we end up with this. And then make sure your calculator is in degree mode. And then you need to type that in. Now, there's a couple different, this potentially could give you issues, so I want to make sure that you eliminate this pretty quickly. If you type this in like this, actually I think that will be fine this time. But your calculator is very, very, very strict about order of operations. So multiplication and divisions at the same time, so it's multiplying these 2 before it's dividing this, which is actually what I intended on this one. But sometimes if y'all just write it in your calculator the way it looks on your paper, it's not going to work. So in theory, to be safe, you should always want to put parentheses around your numerator and parentheses around your denominator. Even if it's not needed, it doesn't hurt, but sometimes that's what you need to get the correct answer. Or, I'm not real familiar with this one, but some of you guys like this one better. If you hit alpha F1, option 1 here, numerator over denominator, you can hit that, and then it makes it look like a fraction, so then you can make it look like what's on your paper. Because in mathematics, when we write these big fractions like this, we don't say it, but we actually imply that there's parentheses around the numerator and parentheses around the denominator. So again, it didn't matter on this question, but it will matter at some point. based on order of operations. So make sure you're either putting parentheses around your numerator or denominator, or doing alpha y equals and writing it like a fraction. But anyway, so all of that to get that A is about 14.142. 42. And now for side C, be careful not to think that you could use Pythagorean theorem now. Pythagorean theorem is right triangles only. So side C, we're going to need law of cosine or law of sines again. Or I guess technically you could do law of cosines at this point if you prefer. But if I'm trying to find C, I have to put that over the sine of angle C. And then I either have to put that equal to A over the sine of A or B over the sine of B. I'm going to recommend that you don't use A over the sine of A because this A is rounded. And if you're using a rounded number here, then this answer for C gets further off. Try to just use B over the sine of angle B. Plus that way if you made a mistake on this one, if something's wrong with it, you're not using the wrong answer and making more wrong as well. But undo times with divide. Make sure you put that in your calculator carefully. Again, sometimes it doesn't matter if you put thought into order of operations, but sometimes it does. I'd hate for you to miss it just because of that. Make sure your calculator's in degree mode. Should just stay in degree mode. And I'm getting about 27.321. And as I preached several times last semester, good idea, since it only takes 5 seconds, make sure your smallest side is opposite your smallest angle, and your biggest side is opposite your biggest angle. And if that's true, then that guarantees the medium-sized side is opposite the medium-sized angle. Doesn't guarantee your work is right, but it would guarantee that your work is wrong. So this part was the law of sines part. Anything about this stuff at the bottom y'all need to ask about? Anything specific? Okay. So if you were having trouble with number 5, I think that should help you with 8 and 11, unless you need to ask about the degrees, minutes, and seconds. Then 39 and 41 are asking you to use one of those new area formulas. So let me give you a little bit more time, and then I'll let you guys speak up and tell me which ones you're having trouble with.
When you're using the degrees, minutes, and seconds thing, how do you round it? Like,
I wouldn't round it at all. I would probably store it. I remember the store button.
yeah.
I would just store it in for like X or something, and then just use X when I use it.
Okay, because like I thought for the one that it was like 42.6 but in here it just says like 42, so should I just say I don't know, maybe I did it wrong.
Yeah, 42 degrees and 4 minutes. 4 minutes would be 4/60ths of a degree. which is not very much. Do you have 0.0666 repeating? Or did you have 0.6 repeating?
I had 0.6. Is it
Yeah.
0.06?
It's 0.06.
Okay.
So yeah, there must be something else off in there. You would?
I just need to know what 83.
Okay, so that's degrees, minutes, and seconds. So you got 83 full degrees. And then you have to remember that a minute is a 60th second. So in your calculator, you do 83 plus 20 over 60. And then that changes it to decimal degree. Just use that for angle A.
Okay, I just use this formula.
Yeah, they're the same thing. Yeah. It's just that I use this for finding side lengths because it's already in the numerator. And I use that for finding angles because it's already in the numerator. But they're really the same formula, just flipped up. So.
So like if you ever miss class, and I always have like this agenda specific to the snapshot, so I always recommend that they bookmark that. This is the website where I'll put like solution keys, any videos I make in class, all that kind of stuff, all the extra resources there. I don't do near as many web designs as Ms. Thomas does, but you may want to go ahead and sign up for that so that when we do get the one, you don't have to worry about it.
All right, it looks like it's been about 8 minutes. Is there any that you're having issues with that you'd like me to help with while y'all are here? Okay, we still got about 30 minutes, so still a ton of time. But as always, feel free. Yeah, go ahead.
On 11,
Mhm.
I got A right, but I didn't get B right.
Okay. All right, if it would benefit you to follow me on number 11, then please do so. Otherwise, continue working. Okay, so number 11 does not draw a triangle for you, but you're welcome to draw one. But I know one thing that, especially since it's been a month at least for some of you since you've used degrees, minutes, and seconds, this does show up on our quiz, I believe, and so I did make sure there was a couple homework questions here. But 83 degrees means you have 83 degrees. Those are full degrees. You need to remember that minutes are a 60th of a degree. So at some point in your calculator, you need to say, what is 83 plus 20 over 60? And that's 83 and a third. (83 1/3 degrees). So that's a lot easier to work with than 83 degrees and 20 minutes. Now, since I'm going to have to use this, and this may have been what happened to you, if you round this and then you use the rounded amount, your other answers are going to get further and further off. So A, you can keep up with all the decimals, which is not the best idea because that's still technically rounded and it's more work. Or use the store button. So I don't think we used the store button too much last semester, but we definitely use it more this semester. I'm going to click that and then I'm going to store it for A. Since it's angle A, it makes sense for me to store it in angle A. That way, anytime I need angle A, I'll just type in A and it won't be rounded. It keeps up with what that exact value was. Okay, so that being said, it looks like angle B should just be the 180 trick. 180 minus this angle that I know, minus this angle that I know, that I just called A. So 180 minus the angle A that I just found, minus the 54.6 that was given to me, and this is what I got for angle B. You okay with that? Now again, to write this on my paper, I don't want to write 8 decimals. No one's interested in 8 or 9 decimals worth of stuff. That's why we usually round to 3. 3 is usually plenty. 3 is what they expect on the AP exam for AP Calculus. But that is a rounded amount. Now, I don't know if I'm going to use this later in this question, but if I use it, I do not want to use the rounded amount. It's going to make my other answers further and further off. So I don't know if I'm going to do it, but I'm going to go ahead and store that as B because that's how big angle B is. And then it keeps it exact, and I don't have to worry about it, and I don't have to type out all the decimals. Okay, so all of that to get to finding A and B here. So if I want to find side A, I need to pair it up with the sine of angle A, and then I have to set that equal to B over the sine of B or C over the sine of C. And since I have angle C and side C, that's the one that's going to be the easiest to work with. Now I'm writing angle A here, but I actually know how big it is and my calculator knows how big it is. So in my calculator it looks like 18.1 times the sine of what it stored for angle A divided by the sine of 54.6. And I know I don't need parentheses here, but I'm going to still put them just in case. Okay, and then it looks like that's what the exact value of B would be. I think that was B. No, that was A. A is 22.055. It's okay to round your final answer for convenience. No one wants to look at 8 or 9 decimal worth of work, but don't round in the middle of the question. Okay, are you okay with that one? Okay, and then for B, if I want to find side B, I have to know angle B. And then I can set that equal to A over the sine of A or C over the sine of C. Now again, there's nothing wrong with using A over the sine of A. It's just that I did some work to find these two. So in theory, I may have made a mistake, whereas angle C and side C were given to me in the question. So I know those are correct. So even though it doesn't matter mathematically, I still feel better using the two that were given to me. So now it looks like B would be 18.1 times the sine of 42.067 degrees all over the sine of 54.6 degrees. Gives me about 14.877. But again, make sure you do practice putting that in the calculator, because that's really one of the few ways that you can miss some of these. 14.877. And since I spent about 5 minutes on this question, again, you're crazy if you're not making sure your smallest side's opposite your smallest angle and biggest side's opposite biggest angle. So my guess would be if you got angle B wrong, it's probably because you rounded angle A, which means that you rounded angle B, and then you probably had a different angle B right here, which made your side B look different. And that's the trouble with rounding in the middle. So either keep up with all the decimals or practice using the store button. Store button's better and it's easier, but if you don't use it sometimes, then you guys won't be able to use it when you need it. So, okay, I will leave this work up for a few minutes so that if anyone needs to speak up and ask for anything specific about it, you're welcome to. Yep.
What is, are you gonna give us the area formulas too?
Yes, we'll give you the area formulas too. Or more just want you to be exposed to them and know that they exist and be able to use them. But I mean, I guess to be really safe on the ACT, you probably should memorize these. But from the questions we've seen in the past, you just need to be familiar with them to know what to do. So. Still got about 15 minutes, so I'll stop bugging you for questions, but please speak up. Let me know which ones you'd like me to discuss with you. Try to get as much done as you can in class. Please try the other ones for homework, and then just like last semester, I will give you a chance to ask questions from these, but you do need to have tried them all to know which ones you need to ask about. So,
Can you do 47?
47? Sure. Okay, you do not have to jump to 47 right now if you're not that far, but if you'd like to, you're welcome to. I will record it so you can watch it later. If you don't want to jump ahead. But this is kind of similar to a couple questions we had last semester that were an extreme pain because all we had were right triangle trig. It's going to be significantly easier with law of sines, law of cosines, because we don't have to narrow things down to right triangles. Okay, and it sounds like we're supposed to find the distance between the fire and each of these towers. So really the other two side lengths of our triangle. Okay, so if you're not sure if you're ready to use law of sines or law of cosines, then the worst case is you just start writing down, start throwing in some numbers into the formula, and then if you've got all but the thing you're trying to solve for, then that's great. It looks like it's ready to go, and if not, it at least gives you a hint. So for example, if I'm trying to solve for x, and let's say I'm trying to use law of sines, x needs to be over the sine of his opposite angle. And if this is 65 and this is 80, then this must be 15. So they kind of did give that one to me. But I have to pair it up with a side length that I know over the sine of his opposite angle. Well, I only know one other side length, that's this one, 30. And I have to pair it up with the sine of his opposite angle, which would be over here. So until I figure out this angle, I'm not going to figure out that side. So for this one, I would say we almost can do the 180 trick in our triangle. We've got 15 degrees, We've got 70 plus some, and then we've got the angle that we really want to know. And for this one, it looks like, I think for this question and the next question, we need one more angle. So a similar trick that we had to do last semester. If we have a north line here and a north line here, we've got two parallel lines. And so if I try to look at maybe this guy as the transversal, this one is in the upper left. Highlight there. This one is in the bottom right. So those are alternate interior angles, and if those two lines are parallel, then those angles have to be the same. And then once I know that, oops, then I really know this angle is minus 180 minus 15 minus this whole thing. Comes out to be a nice even 30, and then side X is just about ready to go. It's 30 times the sine of 15 divided by the sine of 30. It's about 15.529 kilometers, and that seems to be a realistic answer. If I think this angle is 30 and his opposite side is 30 kilometers, and this angle is 15, his opposite side is about 15 kilometers. Again, it's not directly proportional, so it's not supposed to be exactly 15, but the fact that it's close to 15 is a good sign. And then to find this side y, I need to pair it up with the sine of his opposite angle, which I now have. And I can pair it up with these two again. So it looks like the other side would be 30 sine of 135 over the sine of 30, or about 42.426 kilometers. So sure, figuring out this angle right here, of course this is what I would recommend that you highlight in your notes. You got to use one of those alternate interior angles, same side interior angle tricks or whatever, but the actual plugging into law of sines and solving and using your calculator is really pretty easy compared to the alternative of trying to use right triangles a bunch of times. So all right, same thing. Let me leave this one up for just a moment. Make sure no one has any questions, and then I'd be happy to take maybe one more that we would have time for that not rush through. But again, I will take whatever questions y'all could not figure out next time, but make sure that you have tried all of them, because that will be your chance to ask the questions you need to ask. Has anybody signed up for the ACT prep class this semester? No? Okay, one little rant I kind of want to go on, just because I'm not sure why things work out this way. But this top one you guys recognize as Pythagorean theorem, and we know Pythagorean theorem only works on right triangles, correct? And then this is a new formula that I showed you today. This is one of the law of cosines formulas, which is almost the same thing, except minus this. But if it was a right triangle, and you were plugging 90 degrees in for angle C, what is the cosine at 90 degrees? Cosine's the x value. So if this is 0, you see how all of that goes to 0 if it's a right angle anyway? So this only works for right triangles. This guy always works. So to be honest, I don't know why you guys don't learn this instead of Pythagorean theorem. And if it happens to be a right angle and all this goes to 0, fine. And if it doesn't, then good, it's not supposed to. But this one always works. It's much more useful than Pythagorean theorem. And it doesn't mess it up either. So anyway, just an observation I've had in the past. There was also one announcement we got an email the other day, and I don't know if this went in the student announcements or not, but of course soon we'll be doing CAP process where you guys will sign up for your classes for next year. If you plan on taking any NWAC or NWTI courses, they expect you to have a certain score, ACT score, so like you can't take college algebra without a certain ACT score. So if you don't have that score, it's too late to do the ACT, but then there's a test called the AccuPlacer that you can use. That's given by the school that can be in place of that can help you get in. But this email said it'll be administrated on certain dates with limited number of seats. If you know you're interested in signing up for one of those courses, don't procrastinate, because the last ones, other people probably will procrastinate, and then you may not get to take it because there's only a certain number of seats, and there's not any exceptions or extensions. All that stuff is run through NWAC, and we can't bend those requirements even if we wanted to. First exam date is February 9th. The link is in student parent announcements and on the FHS website. So not necessarily math related, but any NWAC courses, concurrent courses, NWTI courses, make sure that if you don't have the ACT score to get in the courses you want, you sign up for those AccuPlacer tests and get a reservation before they fill up.